Hello,
Hello.
screen visible? Huh?
Yes, sir.
Okay, so we have seen collection framework. So I want to put an end to that collection framework with yesterday's class because it is more advanced concepts. Uh, for you to understand also, it will take be a little bit tougher. If the time permits, let us continue with some more concepts because it is a big topic, very huge topic. There will be lot of classes available. It is not a small thing. That itself is a single subject like kind of a thing. So I cannot cover all the topics in collections in this course. I just gave you some introduction to collection and some basic classes and interfaces that you can use in most of the applications real-time applications that I have dealt with. Remaining thing, if you want, you can pursue after completing the course. I'll give you a material kind of thing so you can refer to that one and do that. So now today I want to start with a new topic called applets. Before going to deal with applets, I would like to say something about how the programming will be in Java from now on. It will be a little bit different with the previous. For what we have been doing is we have been developing uh, writing programs. We've been writing programs which are console based. Tell you what is console based. So from now what we are going to see is GUI based program. So what is this console based and GUI based? So now look at this one, command prompt. So how you are running a program, any Java program. So you move into the directory in which your program is saved, and from here you compile the program and run the program, give the input to your program, and take the output from the program. So this black color screen that you're able to see, which is called as command prompt. So this is the interface. This is acting as an interface between the user and the program, Java program, right? So for any program or any software, there will be some interface using which the user will be interacting with that software or program. Okay, so if there is no such an interface, then the user of that software will not be able to use that application of that software, right? So these interface is nothing but it is like a mediator which acts as a mediator between two entities, right? So for example, you want to withdraw money from your bank account. Earlier, in olden days, some 30 years back or some, we go to early 90s. So there were no ATMs in those days. So how people used to withdraw money from the bank means the bank people, you have to personally go to the bank branch, and the bank manager and the accountant, all those employees, what they'll do is they'll be maintaining passbooks for every account holder in that physical passbook. Physically, they are not stored even in computer, right? And everything, each amount that is being withdrawn or deposited by the customer will be noted in a big ledger books, on which date how much amount you have deposited and how much amount you have withdrawn. All these details they'll be writing in their ledger books, as well as they'll be updating it in your passbook for your information, for your sake, right? In that way, if you want to perform any transaction with the bank, any interaction with the bank, whom you go and with whom you're going to interact with, people, the accountant or the manager of the bank, whoever it is concerned, right? So they are nothing but called as interface. So they'll be acting as an interface between the bank, your bank account, and you. So you will be able to operate your bank account only with the help of those people. So now in modern days, without going to the bank physically, we can withdraw money from our account by going to a nearby ATM machine. So that ATM machine will have some software, and physically it will have money loaded inside that machine, and you will be interacting with the bank with the help of the screen that is visible on your ATM machine. So you'll insert your card and you'll enter your PIN number, all these things. So that software will be now acting as an interface. That screen, the ATM machine screen, will be acting as an interface. So similarly, just like how it happens in real-time application for any programming language, any program written in any programming language, or even any software. Software is nothing but set of programs, right? So every program that matters, they'll have some interface so that the user of the program will be able to interact with that program. So from here, this black screen now is my interface. So using this interface only, I'll be interacting with my program. So interacting means I want to compile my program. Then I'll type Java C here on the screen and specify the file name and .java. And soon after I strike the key, the program will be compiled. That particular program, whichever file name you have mentioned, that program will be compiled. After successful compilation, if there are any errors, it will be showing that also, right? After successful compilation, then again I'll type another command to run the program. So once you run the program, it may ask you to enter some input value. Then you'll give that input value here itself. Then you'll get the result back as output here itself. So this entire thing is nothing but acting as an interface, right? So these type of interfaces, this blockchain kind of interface, we call it as a console-based uh, interface. Okay, it is a console-based interface or command user interface, you can say. So console-based is nothing but you can say CUI. CUI stands for Command User Interface. Why we call this as Command User Interface means everything works on commands. So Java C is a command which will tell the Java compiler software to compile this so and so file name. Java is another command which will tell your Java runtime system to run your so and so class file and give the output. Right? So for everything, you need to use a command there. So that is why we call such a user interface, this kind of user interface, as a command user interface. Apart from that, if you have a GUI is nothing but graphical user interface. So now my desktop computer screen, we can call it as a graphical user interface. Earlier, before 1995, this Microsoft Windows operating system was not there. Then people used to interact with the hardware of the computer using this command prompt from here on. To create a folder, they'll use a command, make directory MD, right? Say for example, currently we are in which folder? Java Y folder. And where is this folder available? In D drive. So let me go to the D drive. So in D drive, we have a folder called Java Y. So here I want to create a folder. So how I used to do, use a command MD or make directory. In whatever folder you want to create, that folder name you can give here. Say I'm giving test, right? So is there a folder called test here? There is no folder called test available already in this Java Y folder. So now when I click on, when I strike the enter key, automatically this folder will be created. So now you look at, so look at this one. Folder test is created. Earlier it was not there. So look at the time and date, November 4th, 2020 at 8:19 exactly, same time, right? So this is how everything used to work. Now you want to move into that folder. You want to open that folder. Then you want to type change directory test. Now currently you are in which folder? In D drive you have entered into Java Y and then test. Right. So here you want to save files. You can save files and so for everything you used to use command only. So such an interface, this kind of an interface is called as a command user interface. But now look at this one. Instead of using this test here, I'll delete this test folder here from here. Because this is using it, you'll not be able to delete. So now if I want to create a folder here, instead of going to that command prompt here from here, creating a folder by using the command, I can directly right click, select new a folder and type a folder name like this. So this mechanism, which is simple, everyone can use. This is called as graphical user interface. You need not to type any command to create a folder. Directly simply right click on anyone who doesn't know computer science engineering, who is not a computer science student also, he can operate this one, graphical user interface. Whereas if it is a command user interface, only a person who knows all the commands, only he can operate the computer. Whereas here now using this graphical user interface, anyone who is not even well educated also can operate the computer, right? So such type of interfaces are called as graphical user interfaces. Everything is represented in the form of graphics. So now I want to access my computer. I want to see how many partitions are there, what are folders available on my computer. Then I'll click on this graphical icon. So I'll be able to open the all the directories in my hard disk. Then I can navigate into each and every folder and find whatever I want. Right? So this everything is simple. Is made simple and very easy. So this is nothing but called as user friendliness. So when graphical user interface came into existence, the task of the user of using the computer hardware has become very simple. Nowadays, everyone is operating computer. But in olden days, somewhere before 25 years, in early 90s like that, so it's very difficult for a person to operate a computer. Everyone will say if somebody is using a computer, then they'll say, "Wow, he's a very great, talented person. He's operating computer." That is how people used to look at them. But now that is not the case because of user friendliness that we get from this type of operating system called graphical user interface based operating systems. Right now, coming to our Java context, why I have to say about these user interfaces. So till now, whatever programs we have created in Java, they have been working. We have been working only using console from here. Right? So the programs are operated only with the help of this console. So that's why we call them as console-based programs. But now, with the concept of applets, with the introduction of applets, and soon after applet, we'll see another concept called AWT, abstract window tool. These two topics are interlinked with each other. So, combining these two, we are going to see the next coming programs by using both these applet concept and AWT concept, abstract window toolkit concept. Okay. So, using these two concepts, we can create programs in Java which will be GUI based. It means the output of that program will be a graphical user interface. Okay. So, that is what I want to tell you before beginning the applet concept. So when we start using applets, these applets are provided the API. We call we have something called API. API stands for Application Program Interface. So what do you mean by Application Program Interface? Any programming language or any software package, it will provide us with some built-in functions or methods or classes. That matters in Java. We have built-in packages, and packages contain classes. Classes contain methods. So I've discussed about this API even during the introduction of collections. Collection is nothing but a framework, and it provides us some interface. So what is that interface means? API means what? API consists of some set of classes and interfaces which contains methods which can be used ready-made. So in the same way, for applets and for these GUI-based programs also, the API is provided through two different packages Java called java.applet. This is one package. And second one is java.awt. So these two packages contain some predefined set of classes and interfaces. And again, classes in turn will contain some methods, so using which we need to write our program from now onwards. Okay. So these programs, when they are run, they will be generating a graphical user interface window, a separate window, so which you can minimize it and close it, which you can operate on. By using a simple applet, we will not be able to do much operation. But once we start creating programs using AWT, we'll be able to perform some operations on those graphical user interface window. Just like in HTML pages, how we can enter some text fields will be there, some radio buttons, submit buttons, all these things will be there. In the same way, using java.awt package with the help of classes defined in this package, we can create such kind of graphical user icons. Fine. So let us begin with this applet first. So what is an applet means? Applets are small applications. They are Java-based application programs, and this can be accessed over an internet server, just like client-side programming environment is there, right? So, for example, you must have known about web application. So, client will be operating from one computer, and the actual application program will be located somewhere on a remote computer called server. So there will be some request and response going on between the client and the server. Right? So the same way, this applet, what is an applet means? It is a small Java program which runs over internet, right? And once you get send a request for this applet from the server, this will be automatically installed on your computer and runs as part of your web doc. But there are many ways. We are not going to see how to run this application in a browser. But we are going to see using with the help of another tool provided by Java called Applet Viewer tool. There are two ways in which you can run Applet programs. But we'll see the approach with Applet Viewer tool. So I'll tell you about that Applet Viewer tool also. Just like Java C commands that we use to run the compile and run the Java programs. So similarly, there will be a tool called Applet Viewer tool to run an applet program, to launch an applet program. So we'll be using that tool. So I'll show you that one also, how to do that practically once we start writing the program. As of now, what is an applet means? Applet is a small Java program, or it can be a small. It can be called as a small application that can be accessed on an internet server, transported over the internet, and it gets automatically installed on your computer and runs as part of a web document. After an applet arrives on the client machine, it will have a limited access to resources. Limited access means the applet that is transported or received from a server to your computer, that it will not have complete access to your computer. That means it will not be accessing the each and every part of your computer, all the data that is stored on your computer. If it does so, what is the meaning of it? There is no security for your computer system if you access an applet program, if you run an applet, right? So that's the reason why these applets will be given a limited access. Limited access in the sense, the access that is required to run this applet program on your computer locally. only to that extent, to access in the sense to occupy some space on your computer so that the application applet program will be installed on your computer, and then use some space from the RAM to run it and utilize the hardware resources. That's it. Right. So that is why we say it has limited access to resources so that it can produce a graphical user interface and run complex computations without introducing the risk of viruses or breaching data integrity. So why it has been given limited access means so that it will not create any threat to your computer by introducing viruses into your computer or accessing some unwanted data from your computer without you doing all these risk activities. It will be given only a limited access. So what is the purpose of that limited access means? So that the program gets run and the user interface will be displayed for the user. Only to for that purpose it will be accessing the limited resources. Okay. As you will see, applets differ from console-based applications in several key areas. So console-based applications means just before we were discussing about console-based programs. Right? So console, all those softwares that are designed in using such a program, they are called as console-based applications. Now look at this program. It's a small program. We are importing two packages, as I told you earlier. So to write a simple applet program, also, what we need to do is we need to uh, import these two packages. One is AWT, the other one is Applet. So I'm importing the complete package. Import java.awt.star. Similarly, Applet also java.applet.star. So to create an applet, what we need to do is just like in multi-threading concept. To create a thread, what we have been doing, we have either created a class which extends the uh, thread class or which implements the runnable interface. Right? But coming to here, coming to applet, we don't have interface. We only have a class. The class name is applet class. Applet applet class, A capital. So it follows the Java's naming convention. So this applet class is defined in which package? In applet package. So you need to import this applet package into your program. So we have already done that. So first thing, to create an applet, what we need to do is create a class which will extend applet. Then within this class, you observe there is no main method. So till now we have been writing programs in Java which contains at least one class, and if there is only one class, then that class also contains the main method. But from now onwards, what we can do is we can write programs without the main method. Okay. So now this paint method that we have defined here will act similar to a main method in console-based program. So far whatever programs we have seen, they are all console-based programs, right? So for those console-based programs, main method is the important thing. It is the starting point of execution. So similarly here for applet programs and AWT programs, this paint method will act just like a main method. Okay. So this paint method uh, is overridden here. It actually is part of applet class, but we need to override that paint method. If you redefine the method which is already defined in superclass, what do we call it? We call it as override, right? So this paint method it will receive an object of type graphics. Graphics is another class. It's a predefined class which is part of this applet and AWT packages, right? So we have already imported those two packages, right? So it receives an object of type graphics class, and this graphics class has a method called drawstring method. So how to call a method of a class? By using the object of that class. So already we have a G as an object for this graphics class passed as parameter to the paint method. So using that, you can call that drawstring. So what is the purpose of this drawstring method? Means it will draw a string on your applet window. It will create a applet window, a separate window, and in that window, it will display this message, a simple applet. And look at the other two parameters that we are passing. We are passing three parameters totally to this method drawstring. First one is a string parameter because it is enclosed in the double quotes. We have to assume that this is a string parameter. Second and third parameters are integer parameters. So these two parameters represent the axis or coordinates on in a coordinate system. So in mathematics, in coordinate geometry, we'll have something called quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. Right. So at the center, you'll have an origin. You'll have an x-axis and y-axis. You'll have positive values on the right side of x-axis and negative values on the left side of the origin. And on the y-axis, above the origin, you'll have positive values, and below the origin, you'll have negative values. So these axes will divide the entire available space into four different regions, which we call them as quadrants. In first quadrant, x value and y values will be positive. Second quadrant, x value will be negative and y value will be positive. Third quadrant, both will be negative, and in fourth quadrant, x will be positive and y will be negative. Right. So this we know. So if you consider one quadrant here, instead of having a origin at the if you take the first quadrant in which both x and y values are positive, assume this entire applet window screen as a uh, first quadrant of your mathematics coordinate system, coordinate geometry system, right? So if that is the case, where will be the origin? Origin will be at the bottom left corner, but here we'll change it to top left corner. So in our applet window, the top left corner is called as the origin, and as you move from left to right, this is called as x-axis and this is y-axis. So you need to mention at which point in your quadrant you want to display the string applet. Okay, so I am giving 20 comma 20. That means x value is 20 and y value is 20. So uh, at that position, the string a simple applet will be drawn. So this is the purpose of the simple program. But before running this program and all, we need to discuss a lot of other things related to this applets. So after completing them, then we'll start writing the actual applet program, and then I'll show you how to run this applet program. So I already explained you about this one. Applet begins with the two import statements. AWT stands for Abstract Window Toolkit. And what does this AWT contain? It contains support for a window-based graphical user interface. And applet class also is contained in applet package. All these things I have explained to you already. And even the paint method must be declared public. And even if you look at the class also, simple applet is also declared as public.